In this video, we continue where we left off in the previous video, and we will write some queries. Starting at slide 17, we will build a few queries that include time and date data types and some data conversions, as well as joining foreign keys and primary keys in related tables. If you're not logged into the grocery store database, you should do so now, and you should follow along. Also note that the answers to these queries are on the following slides, so try not to look ahead. Try to do the query on your own first before you look at the answer. The first query, using the grocery store database, what are all the records in the transaction table that took place in 2012? The result set should be ordered by transaction ID in descending order. This is arbitrary. It's rare that you will be asked to do something like this, but you may. Your customer, your domain expert may know that there is a transaction table, but typically you'll be the one deciding that the transaction table should be the object of your focus, and you will decide how to query that table. Let's go to SSMS. I am logged in. I've accessed the grocery store database. Create a new query. What are all the records in the transaction table? Select all, or select star from T transaction. 2012 would be my filter. That means I need a where clause. Now I'm stuck because looking at the table, there is no year column. It would be nice if there was a year column and I could just filter on that, but the closest thing I have is date of transaction. So how do I get the year from the date of transaction? And again, sometimes it's useful to look at the data. It's not always useful, but sometimes. And I can see the date of transaction appears to have the year in it, and that's what I need. I don't want the month or the day, I just want the year. At this point then, I need to know how to extract the year from a date data type. Let's assume that we don't know how to do that. One way to find out is to use Google. SQL Server, extract year, and it looks like SQL Server extract year from date is something that has been asked before, and Google knows it's popular. Let's see what we get. So there is apparently a method called year. Let's look at that. This is an authoritative source, Microsoft.com. Microsoft owns SQL Server. That sounds like they're pretty trustworthy. Returns an integer that represents the year of the specified date. Date is in italics, meaning that it is a data type that contains a date. The syntax looks pretty simple. Year with the date in parentheses. We typically uppercase function names. SQL Server is SQL is not case sensitive, but we typically uppercase the function names. Year. And if you look at the columns again, I need date of transaction parentheses, and I need a filter. Date of transaction equals 2012. Does that look like it will work? What are all the records in T transaction in 2012? Therefore, using an equal sign says that whatever the year is in each row of the table, it must be 2012 to be included in the results set. And I want to order by transaction ID in descending order. Select star from T transaction where year extracted from the data transaction column is 2012. Order by transaction ID descending order. It processes each row in the table. If the row in the table meets that criteria, if it meets that filter, it's included in the results set. Let's see what we get. We got 562,725, and then descending from there, look down in the lower right hand corner. There are 8,649 rows. That makes sense. Let's look at the following slide to see what another answer might be. In this solution, I did a little differently. Just to illustrate that there's more than one way to solve a lot of these problems, I used date part instead of year. If we go back to the Microsoft SQL Server documentation, it says year returns the same value as date part. They are equivalent functions if we use them this way. Everything looks good. The solution to the problem then is, or one solution is to write this query. We took all the columns from the table, that's what the star means. We extracted from the transaction table. We established a filter by extracting the year from the date field. The year must be 2012. We ordered the results by transaction ID in descending fashion. What if I only want the top 5 records? I don't want 8,000 records. How about the top 5? Can I do that? There is a syntax then to limit the results set. Since I asked for descending order, I just got the top 5 in descending order. Let's look at the next query. Again, using the grocery store database, what are all the transaction ID values in the transaction table for transactions that took place on Tuesdays? Whatever the results are, we want them ordered by transaction ID in descending order. In this query, I want transactions on Tuesdays. We've already seen that the date consists of a month, day, and year in a single field. We have to extract the day of the week from that date. Let's start over. We're only selecting a certain column from the table. Now if you look at the table, you can see there is a transaction ID in the transaction table. The reason we have the squiggle is because SSMS doesn't yet know what table we're referencing and it's assuming the worst. We'll ignore that for now. We provide an alias. The reason for the alias might look silly in this case because it's the same as the field that we're extracting. The column name is transaction ID. The alias is identical, also transaction ID, but imagine if in a year this column in the table was renamed to something else, trans ID or TID or any other value. This would still persist, and that would allow everybody that was using the query to continue using the query because we have the alias, which means we can rename the underlying fields in the table and still have a useful query. We're extracting from T transaction. The squiggle goes away now because SSMS is satisfied that we're referencing a column name that is part of a table name. In this particular filter, we need Tuesdays. So how do we get the day of the week from a date? Let's try the Google again. Again, SQL Server, date, day of week seems to be popular. We're not the only ones doing this work. Let's see what we get. And there's a function called datePart. Again, this is an authoritative source, Microsoft.com. We could use other sources if we like. The first two are actually Microsoft.com. The third one is Stack Overflow. It might help us too. Let's stick with the Microsoft source in this case. The function looks simple. Call the function datePart. The first argument is what datePart that we are interested in. And if we scroll down, weekday appears to be DW. The pink is good. That means that SSMS realizes that datePart is an existing function name, that we didn't just make it up. And our filter needs to be in single quotes because it's a string. It's the name of a day of the week. We could stop here if we like and run it and see what we get. Didn't quite work. Conversion failed when converting the var_char value Tuesday to data type int. We have a conversion problem then. datePart is returning a number, the numeric value of the day of the week. I assume 1 is Monday, 2 is Tuesday, but we don't really know. We don't know if 1 is Monday. What if 1 is Sunday? We don't know how the system is configured. And without digging into a lot of detail and possibly having to change things we don't have permission to change, we really want something that returns a day. Then there's no discrepancy over what numeric value that maps to. So if we go back to the Google, let's try again. SQL Server day of week in a word, not a number. Believe it or not, this is a valuable skill for developers. You can open a book, you can read the book, you can browse, You can hopefully find solutions in books. You can also use search engines. And in a lot of situations, when you're solving a very narrow problem, this is an effective way to find the solution. So we're not cheating, we're not being lazy. This is an effective way. This is a style. This is a skill that is coveted by employers. What do we get? We got a different result this time. We got date name, not date part. And we got a second hit, which is Stack Overflow. Let's look at that one. I am trying to get a day name like Friday, Saturday, Sunday, Monday from a given date. And let's verify the tag. The tag is SQL, which is the language, and SQL Server, SQL Server, which is the dialect. And that matches what we are doing. And if you look at the answer, apparently date name might be useful for us. The first giveaway is it has 33 upvotes, which is high. The second answer has 55 upvotes. It's also a lot shorter. And it's saying use date name because it returns a string, the word indicating the day of the week, whereas date part returns a number. Let's try that. We change date part to date name. We execute, and that might be right. I'm not necessarily convinced because if I look at the table contents, I don't really know what days these dates are. I don't know what day was 2017, 10/19. Let's go back and refine this to give us a little more confidence that we are correct. Let's put the date of transaction in our query. We have the ID, which we're going to keep. We have the date of transaction, which we will eventually get rid of. And let's put one more thing in here. Date name, date of transaction. That will become a column in the results set. Oh, my fault. DW, day of the week. It says they're all Tuesdays, which matches my filter. I'd like to see some other days. I'm not still completely comfortable. Let's comment this out. It turns green. It's a comment. It has no effect on the query anymore. What do we get now? Oh, there are some Sundays. There are some Wednesdays. Let's just pick one and see what we get. Let's pick 2012, January 10th. Go back to the Google. Google says it was a Tuesday. Our data says it was a Tuesday. We have a little more confidence that we're getting what we think we're getting. So we can take this out. And in our slide, referring back to make sure we have everything we need, order by transaction ID, descending order. The first one is 562,702, and there are 8,792 rows checking the lower right corner for the row count. we have some level of confidence then that we are getting what we think we are getting. On the following slide, which I'd already flipped to, there is the query that I used when I solved this problem. The next query will require us to join two tables with a common field. One table will have a primary key, the other table will have a corresponding foreign key. The question to be answered: what product UPC-A codes are manufactured by ConAgra Foods? And the results should be ascending by UPC-A code and just have the code, that's all. We've been given the order of the results, we've been given the contents of the results, what column should be in the results, and we have to combine or figure out where the information is in our database. We've got some clues. We've got product. There might be a table called product. We've got manufactured. Maybe there's a table called manufacturer, but we'll dig in and look. Let's look at the product table. Now, since I'm writing these queries, I'm making your life quite a bit easier by giving you cues, by giving you clues such as product and manufacturer. If you're not sure, ask. I'm looking at the product table. There's a manufacturer ID, and look, it's a foreign key. What's it a foreign key into? What table does it relate to? Well, if you looked at our naming conventions and you've studied the database, you realize that there is a table called manufacturer that will have a primary key with the same name. Again, in the real world, this might not always be the case. They might have different naming conventions. I'm doing this because it works for me, and it's a lot less guesswork for you since you're new at this technology. So when you see a field that ends in ID and it is not the primary key, then it is almost always a foreign key, and you can certainly verify that. If you want to go farther, you can look at the design of the table, and you might get an error or a warning when you bring up the design. That's fine, it won't bother you. Select relationships, and there's one called product underscore manufacturer, and if you look at the columns, you can see that the primary key is manufacturer with a column name of manufacturer ID, and the foreign key is product with the column name of manufacturer ID. You can verify. I'll do that again. Right click, relationships, select the relationship, open up tables and columns, and verify the table that has the primary key in it. You can certainly do that, and you will do that. You will do that in situations where the names aren't consistent and you're just not sure. Let's open up a new query. Select, and what do we want? We want the UPC-A code. I gave you that UPC-A code. And we can make the alias as descriptive as we like. Don't put quotes around it, but rather put the square brackets around it. That lets us embed spaces in the alias. We've got a nice human readable alias, which in our purpose is useful. In some purposes we may not. We'll talk more about that later, but for our cases, make a nice human readable column heading there. Now it's not happy about UPC-A. from T product. Let's just run that, see what we get. Even though we didn't get a squiggle, we still have a problem. The problem, I will tell you, is this dash here, which is just not a good idea. We can hide that problem by putting brackets around this. That will fix it. A dash is allowed in a file name, or a column name rather, but it is a delimiter as well, so it causes confusion in these queries. When in doubt, put brackets around everything. Or an even better solution is don't use that dash. Okay, so we've got all the product UPC codes. Let's put the manufacturer in there, comma, manufacturer ID, whoops. And we run that. Doesn't help us much. Which one of these numbers is ConAgra? I don't know. I have no idea. But I can find out. Let's go to the manufacturer table. It's actually above the product table. And let's browse it. There's ConAgra. It's ID 15. The primary key of that row is 15. The natural key is ConAgra Foods. I could, I'm not going to, where manufacturer ID equals 15. I could do that. And there's only one. But I don't want to necessarily, because what if that got deleted and the manufacturer ID changed? Then that query wouldn't work anymore. What I'd rather do is search for this string, ConAgra Foods. In order to do that, then I have to bring in the manufacturer table into this query, which means I have to join two tables together. Let's get rid of that where clause for now. Inner join T manufacturer on, and let's go back up here and put in aliases for these tables just to make our life easier. The product table will be P, the manufacturer table will be M, so P dot manufacturer ID equals M dot manufacturer ID. There's our join. A little bit less typing because I created these one-letter aliases for my tables. Now what do I get? I get a problem. Look closely at that. The problem is that I added the aliases for the tables, but I did not use that alias up here. And since there is a manufacturer ID in both tables, it doesn't know which one to use. Again, there's two tables in this query, product and manufacturer. Both of them have a column called manufacturer ID. That means this is not completely clear. And I can fix that by P dot. I'm telling SQL Server now that that particular column comes from the product table, not just from either of the tables. Run that. Now I'm good. And if I want to be a little more exploratory, if I want to take more information out of this result set, I can say M dot manufacturer. When I run this, I get the text of each manufacturer along with its ID and the corresponding UPCA code. Hopefully you can see then that I can experiment a little bit. I can modify the result set just to give myself some confidence that I'm getting the results that I want. So feel free to play around, feel free to experiment. That's why we're here. We're not quite done. Where I've got to apply this filter, Conagra Foods, where m.manufacturer equals single quotes, Conagra Foods. Let's see what we get. We get nothing because I probably spelled this wrong. Again, you have to test your queries before you ship them. Make sure that you get the results that you want. What's in the manufacturer table? There is no space between con and agra. Go back here, delete the space. There's the one record. There is one product with that UPC code that is manufactured by Conagra Foods. Referring back to the query again, all I want is the code. We must be precise. All I want is the code. I can take out the other columns that I had added in my results set. The way I did that was by commenting out those two columns on a separate line. Since it's in green, it's a comment. It will not affect the query in any way. It's just something that used to be there and isn't there anymore. There's my UPC code. There's the solution that answers the question I was given. I was asked to provide just the UPCA code for the products manufactured by Conagra Foods. If you submitted this, this would be a correct solution for that query. If you don't like the green, if you find it annoying, you can certainly take it out. In the following slide, there is the solution. I joined the two tables. I set my filter, and I did my order by. I got the same answer, a single product UPC code. I've got a nicely named column in the results set. The name of the column is product space UPC-A space code, which is human readable and very friendly. And it looks like we're good to go on that one. In the next video, we will continue with the next query on the following slide.